So today I'm going to talk about planter considerations, and I'm gonna have to move a little fast. I got a lot of slides, and we're splitting this time. What I would say is the planter is probably one of our most critical pieces of equipment, especially early season, to getting a good stand established, right? And if we don't establish the stand and get a crop up and get it growing, where are we at? We're not going to make yield at the end of the year. We're looking at replant decisions, everything else. So we want to make sure that we've got the crop up, good, even, uniform emergence, when we're moving in and we've set it up for success. All right, when we start looking at a planter, there's a couple of components on there that are really, really critical to look at. And what we've been focusing on are a couple of things. One critical one is downforce. And so as I go to some of the county meetings and talk to some guys, a lot of guys, and we'll talk about it in here in a few minutes, a lot of guys never touched the downforce on their planter. They don't adjust, they don't look at it, they don't really know truly what to do with it. Depth is a given, right? We usually set depth based on crop, and we know where we want to be. We might set depth based on soil moisture, based on soil texture, somewhere else there. But what we need to try to find is that optimal depth downforce relationship that we can produce that timely emergence in the crop. And so if any of y'all follow any of this planter research, I know if we look out of the Midwest, everybody, in my opinion, and it's being recorded, I'll go ahead and let it be recorded, they've beat corn to death with it. They talk about planter stuff on corn, planter stuff on corn. Well, I'm hoping when you get done looking at my talk today that you see it's just as critical on cotton. And I would mirror, I don't have peanut in here, but it's just as, if not more critical in peanut. So a lot of y'all probably rotate those two crops. So let's look at some components really, really quickly, and we'll move on through. We want to talk about first where we set downforce at. That is at the front of this row unit. There's a couple of different methods of setting and or applying downforce to our row unit. So the most basic method is spring tension or spring force here. That's done with this T-bar handle. And if you look at your manual for your particular planter, it's going to range. Your first slot is usually approximately 100 pounds. Usually you have about 4 slots, and they increase at approximately 100 pounds as we move backwards. So we'll go up to about 400 pounds. All right, the other one, if you got a newer planter, it may have a pneumatic air bag right here. And so if you've got that, you're more than likely going to have a compressor in the cab of the tractor and or on the planter where you have a valve adjustment on that to apply the pounds of force to each one of those row units. And if you've done a retrofit system, and I know there's a good bit of you out in the state that belongs to Precision Planting, that's one of the only ones on the market now that have a hydraulic cylinder there. So we would completely replace either the springs and or the pneumatic bag, downforce bag here with a hydraulic spring. So that's downforce. Depth setting. Where do we set depth setting on a planter? That's pretty easy. Everybody knows that. That's this little T-bar handle back here, and we've just got a bunch of holes here, right? So how does that work? When we move that, what happens? Anybody? That's exactly right, Tim. Right. So there's a stop in here that allows the gauge wheels to move up to a certain height. And so that's all that does. It's a very simple mechanical device that just moves where the stop is for these gauge wheels. So when we set that row unit down in the ground, what that allows them to do is to move so far up so that these opening discs can cut a trench of that equivalent depth, correct? So when we get in a harder soil type or a softer soil type, what would potentially happen? If we're in a harder, drier soil type and we're moving a little faster than normal, this planter is going to have a tendency to want to ride out of the ground, right? And when it starts coming out of the ground, those opening discs are not going to cut the furrow that we need to put the seed down there in. So how do we overcome that? We apply downforce here at the front of the planter to keep that depth or maintain that depth. So let's talk about kind of what we've done and what I'm going to cover here, and I'm going to talk about depth and downforce more in depth in just a second. So we've got on research trials, we've run vigor by depth, by downforce, by soil moisture interactions. There's a lot going on there. If you go through and do the math on that, if you know how we set up trials, we've got close to 300 treatments in that. So we got a lot going on in that trial. It takes a lot of land to do that one in. We've looked at hill drop versus singulated, and within that one, we've looked at vigor times population, and we've actually went all the way up to triple hill drop. I'm not showing you any triple hill drop data here today. There's a company that has some new seed plates they wanted to test. That's why we tested those. And then even some speed tests we're not going to go into today, but some speed tests on hill drop to see how fast we can go and not separate those hills. And then on farm, I think this is really interesting. We're doing downforce by soil texture. All right, when we're doing our research station trials, I use basically what I had available here. I've got a 4-row monosim planter Nothing really special about it. We put a new downforce system on it just so that we could ensure that the springs were accurate and new. The planter had sit for about 5 or 6 years without being used. So we used 3 settings, the low, medium, and high. So that's the first 1, 2, and 3 slots on that one. To simulate moisture contents, we put pre-plant irrigation applications up the evening before planting of 0, ½ inch, and 1 inch. And then we picked 3 seeding depths. So if we were dusting it in, if we were planting it normal. And then I like to go a little deeper to see what happens, or assuming that, okay, maybe I had been planting corn or peanut or something, and the guy that hopped on my planter changed my seed plates and didn't change anything else. You know, what's my penalty for that happening? So let's go back to downforce for a minute and talk about some of those interrelationships. And if y'all can see, maybe this room is small enough and this is big enough. This top left picture, I think, does a really good job, and I've seen this time and time again. I've ran this trial for about 3 years now, and in every year we see this result when we're in that drier soil type, low downforce in that ½ inch depth. We see seeds laying on top of the soil surface. The only reason these seeds are even under the soil surface is because that press wheel at the back, I have one of those packing wheels, just pushed them down under the soil surface. There wasn't enough downforce to cut that ½ inch trench, push them down in the ground. Now the flip side of that, let's assume that you were set up optimally for this soil condition, so you were putting them in the ground at about 3/4 of an inch to 1 inch. You had adequate downforce, and it rained on you that evening, but not so much. It rained just enough to wet your soil decently, not so much that you couldn't run the planter the next day, but you had that higher downforce. This is kind of a scenario that may happen if you don't look at changing that. Can y'all see in that picture? It may be hard to see, but what my gauge wheels are doing to that soil? They're actually compacting that soil. They're forming a trench. You can see the side and see where the sidewalls of that trench are actually compacted and caving in that wetter soil type. So keep that in mind visually what that does. And let's talk about some data. So here's the vigor by depth, downforce, and soil moisture interactions. Really busy graph here, but let's break it down. And I think it's really important to look at it all together like this so you kind of get the big picture but break them apart. The week 1 emergence, so we collected emergence at weeks 1, 2, and 3. So I'm showing you 1 and 3. Week 1 is in the dark color. Week 3, is in the light color. So they're paired like that. By color, that's moisture content. So we're at 6%, 7% in the orange, 8.5% on green. So you say that's only a few percentages apart. Does that really matter? I don't know. Y'all look at those graphs and tell me, does it matter? To me, it looks like it matters pretty immediately within treatments, right? We see big differences between those moisture contents. And then what else do you notice? In here, there's my depths, ½ inch, inch, 1.5 inches, and embedded, the 3 bars within the depths are low, medium, and high downforce. So treatment 2, treatment 3, and then repeated by moisture content. So that make it a little clearer what's going on. So now step back, look at the big trends. What's the first thing you notice? The first thing I notice, I have a general, independent of moisture content, I have a general increase in emergence as I increase depth and downforce, right, up to an optimal amount, and then I see a drop or a taper off once I exceed that depth or downforce. When I get high moisture here, notice when I go medium or high downforce, even at 1 inch depth, I start losing emergence. When I get 1.5 inches in that high moisture, I think I've caused crusting issues or major problems where I can't even get that crop up anymore. All right, same thing we're seeing here. My maximized emergence in a drier soil type was at 1 inch depth, medium downforce, 7%. It was about between medium and high downforce at 1 inch depth. Then over here it was low downforce because the soil was wetter. Last thing I want to point out at this graph, I'm going to show you one more of these. This says large seed, high vigor variety. All right, somebody visually average all this data in your head really quick and tell me about, if you're walking through looking at this, what's the average percent emergence you think you get from that field? Okay, 65. I'll go with 65. All right, Calvin, since you answered that one, my small seed, large vigor variety, what's my average emergence there? Considerably less. There we go. So just by changing seed size, implementing those same treatments, same planter, and I planted these in a split plot design. So meaning my 4 rows of my large seed were here, my 4 rows of my small seed were here, side by side. I took all interactions out that I could. So now we see just by switching that seed size, we may lose emergence, right? We're still here at this medium downforce 1 inch depth. That's my highest emergence. And I still kind of see this general trend to a certain extent of increasing emergence and then decreasing after we get over too deep of a depth or too wet of a soil moisture. This is 30% here. We noticed we didn't even get 30% emergence in some of these plots when we had higher moisture and deeper depths, right? I was over in southwest Georgia yesterday and early in Calhoun counties. There's a lot of emergence issues over there. A lot of heavier clay soils, so I'm wondering if there's not some planter issues, right? We see that happen a lot of different places. So, all right, the next question you want to ask me, what about yield, right? Does this translate? Cotton compensates. Does it even matter? Oh, I can't use a pointer today. Here's my yield. And this time, the dark color is my high vigor variety. The light color is my low vigor variety. And I want to point out, so that low vigor variety is a popular variety that's planted in the state of Georgia, right? We plant that a lot. Well, look at what my highest yielding variety was. It was actually that low vigor variety right here planted it where I said was optimal for emergence. So it out yielded that high vigor variety. It's not that it's a bad variety. It's just if I don't plant it good, if I don't set it up for success to start with, because it's a smaller seeded variety, as Jared says in your county meetings, it's hard to get some of those small seeds up and out of the ground. So that's where we're standing, right? The other thing I want to point out, you can look deep into this. We have some paired where there's no difference in yield. But if we get in let's call these harsher or screwed up environments, whatever we want to say, I see some significant penalties with that smaller seed in here. I mean, I see penalties for both, right? When we start getting wetter, we start getting higher, deeper depth or higher downforce. But I see a bigger separation in some of those where that high vigor variety is able to get up and overcome some of that low vigor variety was not. Does that make sense to everyone? And the only reason I point that out, I'm not trying to get you to select varieties. I'm saying if you have spots in your field that no matter what you do year in and year out, you struggle to get a stand, maybe you want to look at another variety for those particular spots or that particular field or something like that. Because if you can't get that stand, we're not going to get the yield. It does correlate to yield in cotton. It compensates, but only so far. All right. This can help you too. Hill drop versus singulated. When do we select one or two of these? We did singulated with a 4-row John Deere. We did hill drop with that monosim. So I want to point out with hill drop, we did a 12-inch spacing on the drops and an 8-inch spacing, two populations. We paired those same populations with my singulated, if that makes sense. So theoretically, in 10 row foot, we would have had the same number of plants. Does that make sense? Exact same population. It's just one was hill dropped, one was singulated. All right, we wanted to keep that standard. Same two varieties again. I'm not listing the varieties. I'll get shot if I list the varieties. One seed depth, we stuck at it an inch. We didn't want to make another 300 treatment trial here. 3 down forces, the same 3 as before, and the same data collection. I'm just going to jump, goodness gracious, my fingers, to week 3 on this one. So hill drops in blue, singulateds in orange. Low seeding rate are the 3 to the left, high seeding rate are the 3 to the right. So the first thing I'm going to point out across that entire graph, what do you notice? Hill drop, and even if you can see the statistics, hill drop is statistically the same on my emergence all the way across the board. I see no difference. So independent of what I've done to it, hill drop's going to overcome it. That's what I see. But I do have, kind of little bonuses or whatever, increases in emergence if I singulate seeds and do a good job singulating them. But if I'm in a poor environment, see that stair step down where we see that level across. So same thing. That's the large seed, high vigor variety. So let's look at the small seed, low vigor variety. Again, you notice if you look at average emergence in here, if you average that, when I jump here, as Calvin said, considerably lower before, we see more extreme stair steps. But again, we still see similar and or higher emergence for singulated cotton if we've planted it correctly. So again, I'm going to step back and make the same statement I just made a couple of minutes ago. If I've got places that I have problem getting stands, maybe I look at either a larger seed and or hill drop, right? Because now I have a tool that I can overcome that. If you don't want to switch varieties, hey, try hill drop in that field. If you're already hill dropping and you're in fields that you're getting really great emergence, why not spread that out and buy some singulated plates? Because we get really good emergence and really good yields out of those. All right, let's talk about yield. It's a high vigor variety. So when we look at it, these are basically the same, but then we start seeing that tail off. As we lose emergence, we start losing yield. Similar here. So hill drop overall is more consistent. We've got the consistency there, but we have opportunities with singulated cotton, you know, to potentially lower seed costs in the field and to end up with about the same amount of yield. Very similar story when we look at the small seed, low vigor variety. Across the board, the blue or the hill drop is pretty uniform, but you notice again here in this case, my singulated did just as well. And then similar here, statistically the same. So really depends on the environment that you're planting it into. Any questions before I move on to the on-farm about those first two research station trials we're doing? Right. Right, so I can say we've not tested that yet when we've looked at it. Our yields are floating around that, this particular year, floating around about that 1,000-pound range. We hadn't got out of those. We didn't get much higher out of that in that particular trial. But I would assume, based on the data I saw there, if you've got high yield potential, you got good soil, you got a really good opportunity to get good emergence, you don't have emergence issues standardly, I would say look at singulating that cotton. You know, I would, when I've been across looking on a lot of the on-farm trials we're about to talk about, and we'll talk about those, a lot of our producers that are really successful in getting emergence up rapidly, you know, they singulate. And we collected, we're in the process of getting yield data from these trials off their yield monitor. So I don't have yield data to show you here. I've just got the emergence. But I would say hopefully the research I just showed you will tell you that the emergence is going to be tied to the yield. So when we see some of those lack of emergence, we'll see lack of yield. So, all right, if y'all think of something, just stop me. We don't have but a few more slides to go through. So we did 4 on-farm trials this past year with cotton. We did some other crops also. Of course, this cotton conference, that's all we're talking about. All of them were 12-row John Deere planters, and I'll rotate around the way we've got them labeled. We were in Jefferson County here. Standard is a John Deere planter, standard meter, manual downforce control is a T-bar handle. And I will tell you, that one we had to get a rubber mallet to move his downforce for the test. He had never touched it. It was seized into place. So he'd never at all looked at it. Grower 2, this was in Pulaski County. He had a John Deere electric meter with pneumatic downforce control. He had display feedback and control on it. So then grower 3 had a precision planting system with a hydraulic downforce control we talked about earlier. And grower 4 had a John Deere standard meter with pneumatic downforce control, but in this case it was manual. So the biggest difference, there was another slight difference, but I'm not going to go into it because it'll point out who it is. But the biggest difference between this one and that one is this one you had to control with a valve in the cab on the compressor. This one had control in the cab where you could increase and decrease downforce, and the same as this one. All right, so what we'd do is go out and collect soil EC on these fields, divide them into zones by soil EC, and then set up treatments. And so once we did this, we'd go out to the producer and say, what's your normal downforce that you select? We want you to plant with that, and then we would take that number, go 50% lower and 50% higher. And so that may or may not make sense till you look at this. We replicated it 3 times just so that we weren't we felt like in his way too long. And so rep 1, rep 2, rep 3, within rep 2, I've got it shown here. There's my downforce 2 that he normally plants. There's a downforce 1, downforce 3. So just 3 passes. But how we did it, so he's planting normally. So he's coming through planting. He gets to our flags. He'll strip his D2, his D2, his D2. We'll change downforce really quick. He'll do D1, and then we'll increase downforce. He'll finish up his last 3 passes on D3, and then we will take and go back to his D2 and let him finish planting the field. All right, and within each zone, if you notice these little lines, what these are is where we went and we geo-referenced emergence. And we went back to those same spots at 1, 2, and 3 weeks after planting, marked them, and collected rows 1, 3, 5, 7, 9, and 11. Every other row at, again, 1, 2, and 3 weeks on 25-foot lengths. So that way we saw, you know, what the change in time was. Change over time in emergence was. That's what I should state. All right, 17 and 18 results. Here's Pulaski County, strip till 1 inch deeps where he was planting. If you want to see, there's kind of how the trial was laid out. His downforces nominal was 200 pounds, so we went down to 100, went up to 300. Some things we can explain, some things we can't. So here, His EC1, his 200 was probably where he needed to be. There was emergence penalties on either side of that for too low or too high. In here, EC2, to me, I'm going to point out and say he probably needed a higher downforce. And then EC3, we see reduced emergence if he went too high of a downforce. So he needed a lighter downforce in that soil. So if he'd have planted where he normally plants at 200 pounds, he lost emergence just because of that downforce setting. Does everybody follow that? In the same way here, if he went on either side, he would have lost emergence. All right? Yeah, so we basically say it's an estimation of soil texture. That's what we're using it at. We can interpret it different ways. We have not went so deep in this project to actually get texturial analysis of the soil, but we're estimating them as a use of soil texture as we break them out. So yes, and I've got some pictures. Just because you're asking that, I'll bump ahead to show you. So when we look in some, this is Pulaski. So this is my lower EC zones, and you see the red there in the higher EC. This is my southeast Georgia. This is my low EC, and this is my high EC. Does that help bring it into fruition? And so I would say EC probably is when you start, and this is a peanut field, but it just shows you a really good difference between that soil EC. I think it really shows you that we're able to use EC as an indicator of somewhat of a predictor of downforce. We're getting there. We're building a base model. That's why we've done all this research, and then we're starting to go into this because we're trying to build a base model so we can give you guys recommendations. If we look and go across our field, this is where we need to change. While I'm on that train of thought, I would state, not to use too much more time, I would state that we were going to work with another producer, and we had a miscommunication, and he had already bedded his field, and we couldn't go run EC on it. And what he did, he had one of the precision planting systems where he could control it in the cab. And he said when he visibly got to what he would call some of the clay hills or had a lot of clay galls, he would increase downforce. He would just push it up when he approached that on his planter, let it stabilize, go through it, and he would back it back off. And so he didn't have EC ran on his fields, but he visually said, as I see more red in my soil, I'm going to bump up downforce a little bit, because he already had saw some instances, he was already caught up to where we were at and what we were trying to test. So I'm not telling you if you got a T-bar handle to get off when you get up to that. That's not what I'm saying. I'm kind of trying to give you recommendations on where you might want to adjust that T-bar handle and plant from field to field. But if you do have a control system you can handle from in the cab, hey, maybe you want to look at little slight adjustments on it. And my hope is eventually we'll be able to create downforce prescription maps based on soil EC to control these to the field. All right, good question. And I answered it probably really too long and too deep. But this was Dooley County. He was in no-till, 3/4 of an inch deep. He was 100 pounds nominal. We went with 0 pounds and 200 pounds. What's the first thing you notice about Dooley County from week 1 to week 3? Do I need to go back? Does that help? There was no difference in emergence from week 1 to week 3. He got all that up within the first week, really, week and a half. I thought that was pretty amazing with that system. That was good, quick, uniform emergence. We saw no more pop up that next week, and that's why we kind of like to do 1, 2, and 3 weeks. We sit temporally when those plants start coming up, right, and see if there is any other interaction going on. All right, so let's talk about what he saw. So in his EC1, this little bit sandy soil, he actually needed to increase a little bit of downforce. And we didn't go over 200 pounds, but I see that slight increasing trend. When we get over here in EC2, hey, where he's running, it looks to be about where we need to be. He definitely doesn't need to lower it, but somewhere in this upper range, that 100 to 200 pound range is where it looks like he needs to be. When we get over in EC3, it's the same way. That 100 pounds is where he needs to be. If he's lighter, he's lost emergence. If he's a little heavier, he's starting to lose emergence. So you saw the pictures. That just kind of visually puts on, oh, goodness gracious, it's so close. Puts on the difference that's there. One more. This is southeast Georgia. This is Jefferson County, strip till at 1 inch deep. So we did 0 pounds, 100 pounds, 200 pounds there. Again, sometimes we explain it, sometimes we don't. Why lower and higher, and then we got a dip in emergence here? We're not sure. Here, D2, we see that he needs to be at about that 100 pound range where he's at. And then over here in EC3, he needs to be definitely not 0, maybe 100 to 200 pounds of downforce, somewhere in that range would help him maximize emergence. You saw that picture. What is this? I'm going to skip on by that for time. So with that, do y'all have any questions about some of the on-farm work that we're starting to do to kind of develop some of those recommendations for you guys? It's I would say it also feeds back in, if you're familiar. You know, we're starting to get some very advanced control system for planters nowadays, and we need recommendations on how to use them. I will be honest. You know, what do we do with them? Where do we set them? Where do we change them in the field? And where do we need to be? So that's what the purpose of some of this data is.
So are those systems very responsive? You change the setting?
Pretty quick. I don't know the full stabilization time on that precision planting system, but it's usually within 50 to 100 foot. It's fully stabilized in downforce, because that one is a hydraulic cylinder. It's a lot easier to put that force on that cylinder. And they have the ones that have the feedback control, they have load monitoring pins on the gauge wheel, so the minute we apply that force, we have a feedback, so it can adjust that to target that force. The other thing you get out of those that you don't off a manual system, independent of the response time of those systems, is we have a consistent downforce. So if I told you you needed 150 pounds in your field, it's going to hold it at that no matter what, right? So if we set a spring's going to try, but if we start seeing different soil types, you're going to see variability in that, where we'd see more consistency too. So, all right, I'll be around for a little while. If y'all got any questions for me, catch me. And like I said, I'll stick around the room with that. I'm going to turn it over to George.
Good morning, everyone. So we're going to change gears a little bit, and apologize for taking an extra minute here, but I made some changes to my presentation while Wes was speaking. I thought of something I wanted to add. So what I want to speak to you about today is some work we've been doing together with all these people that you see listed on the slide at the Stripling Irrigation Park to look at strategies for improving nitrogen and water use efficiency in cotton. And this is the first year of the study. It's a 3-year study, so we've got some ways to go, but we're finding some really interesting things that I think might interest you. I'm a faculty member here in the Crop and Soil Sciences Department. Like Wes and Calvin, who's in the audience here, we're engineers by training, so we tend to look at technology quite a bit as opposed to things from the agronomic perspective. So the issue that I want to talk about today is this idea of sustainability. Okay, so sustainability is sometimes has a negative connotation in our ag circles, and that's because we think that the people from the environmental movements have sort of hijacked this word and taken it to mean that we need to stop farming, need to just make everything into natural forest and stuff like that. But actually, sustainability has a huge effect on what we do in agriculture, and the way we need to interpret it is how we can become more efficient, so that we have higher efficiency on our farms and higher profitability. And all these things get tied together. So there's been quite a bit of research that shows when you are approaching sustainability or trending towards sustainability, that you are also increasing your profitability. In fact, at the Beltwide Cotton Conference a few weeks ago, Cotton Incorporated announced a huge initiative to enroll almost all cotton farmers into their sustainability platform, so that U.S. cotton becomes sustainable certified, and so that the end users, the Hanes, the Wranglers, the Walmarts, can say to their customers that the cotton that we're using is sourced from sustainable farms. So this is a big issue, and this project addresses this issue. And really where we're driving at is we want to produce more crop per unit input. So more crop per unit of fertilizer, per unit of water, for whatever it is. So we want to sustainably intensify what we do on our farms. So I'm going to try and address that. The project I'll be describing here at the beginning it has this nice acronym, FACETS. It's funded by NIFA, but it has many participating universities. It's actually led by the University of Florida. And the goal is to look at how human activity on the landscape is affecting the Floridan aquifer. So those of you that farm in Georgia, that have wells, are more than likely drawing water from the Floridan aquifer. So it's the way we farm, the way people in northern Florida farm. But the aquifer over years has been declining gradually, even though it's an aquifer that gets recharged from rain. It is trending downwards. And the aquifer is also becoming contaminated by nitrogen. So the concentrations of nitrogen that we're finding in the aquifer water are gradually increasing over time. So the idea is that we can find management strategies that will allow us to use this aquifer sustainably for the future so that we don't decrease the water levels and we don't contaminate it. Okay, so what is driving this, and this is, I think, important for all of us in Georgia to understand, is that in Florida, the state has implemented nutrient criteria for their waterways, which means they have laws that say in the rivers, the nitrogen and phosphorus levels cannot exceed a certain threshold. And in the springs, which are fed by the Florida aquifer, they have a very, very stringent level for nitrate nitrogen. Okay? So think about what's going on now with our neighboring state in terms of the water wars, right? They are suing us because they think we're using too much water. The next thing that's coming down the pike is they're going to say, hey, water flows downhill. We're downhill from you. You guys better be doing something about the nutrient levels in the water you're sending us. So we are trying to be proactive and eliminate the potential of this happening. So this project is very complex. It has 40 PIs. My part and Wes's part here in this project is to look at sort of this demonstration and outreach activities that are related to nutrient use efficiency. And the part that's highlighted in the red there, I'm going to describe to you. So what we're doing is we're looking at what we consider cutting-edge best management practices that we can combine together to improve nitrogen and water use efficiency on the farm. And we're looking at our three primary agronomic crops, corn, cotton, and peanut. And all this work is being done at the Stripling Irrigation Park, and Calvin Perry is responsible for making sure everything gets done well there. And Mandy, his new employee, and BJ have been working on it quite a bit. So what we have there is a part of the farm that's dedicated to plot work. There's a lateral that runs from left to right and right to left that irrigates all these plots. The field is divided into 3 big blocks, and each block has 27 plots. And what we're doing is we're rotating the crops from block to block year to year. So as you see here in 2018, we had corn on the left, peanuts in the middle, cotton on the right. In 2019, corn will move after peanut, peanut will move after cotton, and then cotton will be over here where corn was. So that's the way the rotation is. So I'm going to be focusing on the work that we've done in these 27 plots for these crops. And I want to focus on cotton, obviously. We're at a cotton conference, but I'm going to have to interject some other data here to show you what's going on. So here's what it looks like from the air, from a drone view. You can see the cotton in the foreground, the peanuts in the middle, and the corn in the background there. You can see the lateral. Here's a short video just to tell you a little bit more about what's going on while you look at it. So in each of these 27 plots, we have a number of different treatments. We're looking at 9 treatments by 3 replicates of 27 plots. What's also interesting here on the sides, you can see these 2 plots on each block look a little bit different. We're also capturing surface runoff to measure how much nutrient and we might be losing when it rains intensively there. So there's not a lot of runoff because the soils are pretty sandy, but with very intense rainstorms or when we have saturated conditions, we actually have some runoff. Our lateral has VRI control, so we're able to irrigate each plot individually. So we can do 27 different irrigation treatments on those plots if we want to. So one of the things that we decided up front in terms of a management strategy that we're going to incorporate throughout is to use cover crops and do strip tillage. So you can see here, this is the condition of the cover crop late in the spring after we burned it out and we planted. Calvin, do you remember if this is the cotton? Cotton or peanut, anyway. Cotton, yeah. So, Kale's in here too. Kale's also working on this a lot. So you can see that there's quite a bit of cover. So we're doing peanut, cotton, and corn with strip tillage. So the peanut is something that, is not very widely adopted across the state. We had good results. I won't have time to talk about peanut today, but we had good results with peanut. So for the cotton, these are the strategies that we selected as the combination of strategies that we think might have the best impact for improving nitrogen and water use efficiency long term. So anybody here do fertigation on their farm on corn? Danny? Okay. So it's not a very common practice to apply nutrients to cotton through the irrigation system. So we thought we'd evaluate that as one of the strategies. So fertigation is one of our strategies. And basically we're taking, the normal recommended amount of fertilizer for 3 bale yield, doing pre-plant, and then doing 3 applications of the side dress with fertigation. Second algorithm is to use some work that Dr. Porter did when he was a grad student at Clemson University, is to use reflectance data from the crop to develop an Ndvi estimate of how much biomass is out there, and then use that biomass estimate to determine how much fertilizer to put on the cotton. And the third one is to use a traditional, which is pre-plant, and then 1 side dress of 85 pounds. 3 irrigation treatments combined with those 3 fertilization treatments. One is to use our smart irrigation app. The second is to use a soil moisture sensing system, and the third is to use the extension checkbook method. So here is the fertigation process. Calvin was able to purchase a mobile fertigation rig there so they can use it on different irrigation systems. So you see it being applied there. I don't know a lot of details about that, but the gentlemen are here if you want to ask them about it. So here's the schedule of putting on the fertigation treatments on the cotton this year. Dr. Harris suggested that we do this, get it completed before the 3rd week of bloom, so we made sure we did that. It was planted on the 10th of May, so you can see we're well within those limits. The Ndvi data, I'll take a little more time to explain. Essentially, we're using a UAV to fly over these plots. The UAV had a fancy camera on it that captured reflectance in different wavelengths. And then our grad students crunched the numbers and essentially came up with an Ndvi measurement that you can see here on this column for each of our different treatments. Essentially, these were the same value, so all 3 of our treatments that had Ndvi times irrigation got about the same amount of side dress fertilizer. This is about 10 pounds per acre less than the traditional side dress amount. So Ndvi allowed us to reduce that by 10 pounds per acre. And the way this works is, if you look at the graph on the right, you take your Ndvi measurement. This is the curve that was developed first at Oklahoma State and modified by Clemson. You go across here, you find your Ndvi measurement, you pop up, and then it tells you what you should be applying. And the interesting thing is that, if you're below a certain threshold, it means your plants are so small at this time that you might as well cut your losses and not apply any side dress. You're not going to get any yield out of it. And then likewise, if you've got a lot of biomass, it says, okay, cut off the fertilizer, you need to be in the fruiting stage and you don't need to apply anymore. So it's a pretty sophisticated algorithm that's been developed over many years. And then here's our extension checkbook method for irrigation scheduling, our cotton app for irrigation scheduling, and then the sensors that we used for irrigation scheduling. So all these are techniques that are well established. We've spoken about these at this conference in the past. All our plots had sensors so we could measure what was going on in the plots and not get caught up in causing problems. And then, of course, we were getting ready to harvest our plots, and this happened. Many of you are familiar with this horrible graphic of Hurricane Michael coming through. So we went out there the day after the hurricane. This is what our plots looked like on the left the day after the hurricane. A lot of cotton on the ground. I had this naive idea that perhaps we could go hand pick what was on the ground for a few rows and then machine harvest the rest. It turns out that whatever we hand picked and machine harvested was less than what we normally get from those plots. So our yield were gone. I don't know where it went. We didn't see them laying around the farm, probably 2 or 3 counties away. But so this pickup truck is the mechanically harvested yield of 27 cotton plots. Not a lot to show. But what I wanted to show you in terms of yield was what we ended up doing with our corn, because we were doing the corn with some of the same treatments. And I wanted to do this to show you the effect of fertigation, okay? So here with corn, what we did was we had the traditional side dress approach, and then 2 fertigation treatments, one for a higher yield goal and one for a lower yield goal. Essentially, the fertigation treatments, if you look at this up here, all 3 of our treatments had the same yields. There were no statistically significantly differences here. And our 3 different scheduling methods were about the same. There's a corn app we're developing. There are no differences in yield between the irrigation treatments. But look at with fertigation here. So we applied 300 pounds using a lot of applied 300 pounds of fertilizer using this fertigation method, got the same yields as using 200 pounds per acre with fertigation. So these 2 treatments result in the same yield, but we had significantly less fertilizer use. So The same thing with irrigation. The sensors in the app work well. So we think fertigation actually has potential here that needs to be explored. So for cotton, all I can report are the irrigation results because, as I said, the yield was lost. You can see here that the app method and the sensor method reduced water use significantly compared to the checkbook method. Okay, we've demonstrated that over the years, both Dr. Porter and I, so I don't think that's anything new. And you can see here that these are the soil moisture graphs from the 3 different treatments. You know, the checkbook kept things a little bit wetter. Everything else was pretty wet, though. We had a lot of rain in 2018. We also collected a whole bunch of other data that we're using to track what happened to nutrients in the tissue and in the soil during the growing season. And so some of these samples are still being analyzed at the lab. We'll have a full report for that in a few weeks. And we also saw quite a bit of movement from runoff because some of the runoff events occurred after fertilization. So we actually lost some nutrients with the runoff. So the moral of the story here is that we're collecting all these interesting data. Our counterparts at the University of Florida and Auburn University are going to be using these data that we collect to run crop growth and nutrient transport models so that we can say, okay, what if we adopted these management practices on a large scale? What would the effect be on the aquifer? Would we improve the condition of the aquifer or not? And then we have a group of economists, including Ms. Amanda Smith, who's looking at the economics of this. You know, will these practices be economically feasible and sustainable in the future? Because we certainly don't want to have an outcome that says, okay, yeah, this management practice works well for sustainability in terms of environment, but doesn't work well for economics. What's the point of that? No one's going to adopt it. Any questions about this project? Okay, I'm going to spend another 5 more minutes telling you about something else that we've got going on with Dr. Snyder that's a pretty interesting project. So Dr. Snyder has worked for a number of years to look at using leaf temperature of cotton as an indicator of crop water stress. The idea being that when the crop has adequate soil moisture, it's transpiring well, water is moving out of the leaves, photosynthesis is occurring at maximum rates. As water becomes less available, less transpiration takes place, and the leaf temperature starts to increase. And so here you see a false color infrared image of, thermal infrared image of a field that we've been working on. You see there are a lot of canopy temperature differences out there. So Dr. Snyder and others, the way they've been measuring leaf canopy temperature over the years is to put out a lot of these types of thermometers in the field. So they're put on poles, they're looking down at the canopy. You've got to have a lot of them in the field to actually get a good idea of what's going on in the field, because essentially they're looking at 2 or 3 leaves on one plant at a time. And this works. You know, it's very effective in telling you when you should irrigate, but it takes a lot of effort to do. So there's a company, the same company that makes these guys here has now offered a new product. It's this military-grade thermal infrared camera that you put on a mast, and theoretically it looks out over a whole field. And it rotates, so it can take pictures in 360-degree angle. So here's one of the laterals at the Stripling Irrigation Park with that camera. You can see the outlines of different plots. You see there are temperature differences in here. The lateral's irrigating these 2 plots at this time, so you can see that they're wet and cooler. What we're doing is evaluating whether you can use this camera to put it in the field and use it to look across the entire field and see if you can actually detect canopy stress and then determine whether you should be irrigating with it. And what we're doing is we're comparing the camera response to Dr. Snyder's data from the individual thermometers. And I'm not going to belabor the graphs here, but basically these graphs are saying that the new camera works as well as the individual thermometers. Okay, that's it for my presentation. Very excited young lady to be a future dog here.
Or do you think that sentinel camera really looks over as much of the field as they claim it will?
So that's a very good question, Calvin. So the plots that we were working on here, I think the camera was based over here. These were about 400 feet away, 350 feet away. We evaluated the accuracy of the camera compared to the thermometers, and really there was no degradation in accuracy across this distance. And it's very interesting that there wasn't. I fully expected it to be because, you know, the acute angle allows you to see only a sliver of that canopy back there, as opposed to here where you can see the whole plot.
A much larger area than you're showing.
They claim, yeah. So really, it's interesting. We have a conference call with them tomorrow to sort of iron out the details of how we're going to be using it on a field scale. So in 2019, we're going to be moving the camera to a grower's field in Miller County. He's got a big half circle, so we're going to put it at the pivot point without obstructing his operation of the pivot. And the field also has some slope to it away from the pivot point, so hopefully that'll improve our ability to look further.
Would it be feasible to do the same thing with a drone?
Yes, yes. So that's a great question. You know, the question was, is it feasible to do the same thing with a drone? Actually, this project is funded by a program that allows us to work between here and Israel, with partners in Israel, and our Israeli partners are the experts in this kind of work, and they're using drones. However, drones require that you have cloud-free flying time. And, you know, that's a little bit difficult to achieve in our growing conditions here. So we thought that the camera mounted on a mast would give us more opportunities, because you can get this camera to shoot every 10 minutes if you want to. So, you know, whenever there's a window of sunlight, you could probably go out there and do it.
Is it a cumulative, the collective study, is this a single shot or is this a?
So what the company does is the camera, so let's say you want to do it every 10 minutes. It does click, 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 click. It takes frames all across the field, and then they create a panoramic like you see here, and they deliver you this panoramic. Right now, they're not giving us individual temperatures for every pixel in here, so we have to go in there and extract it with complicated software. But our meeting tomorrow is to get them to give us the raw data so that we can extract.
Is it a single shot or is it over a?
No, it's multiple frames over a 2 or 3 minute period while it's going around, and then it does it again, and you get another panoramic 15 minutes later.
It's just at that moment, it's not cumulative over a day.
Oh, correct. I'm sorry. Yes, it's not cumulative.
It'd be like a 6-hour period or something.
No, it's not. No, I think you need to get the crop water stress index. You need sort of instantaneous values. And Dr. Snyder, to overcome the problem with the shadowing from the clouds, is actually doing it at dawn most times. The crop water stress index, he's calculating it at dawn, so before the sun starts affecting it. And we can take these pictures at dawn too, if that's the way to do it.
Could you do it at night?
Yeah, you could do it anytime. Yeah. So this is a little bit pie in the sky at the moment, but I think it has real potential. All right, I think we're out of time, and anyway, I'll be around as well if you'd like to ask any questions or think of something down the line.